Today we're going to look at 1,000 foot lengths of RG6 coax using screen and fixed resolution on the Moore CT100B. Let's get started. Always be sure to properly discharge static before connecting to any high-frequency test equipment and never connect to live equipment. We're going to start things off with our control cable, a 36-inch piece of RG6 coax. Hooking it up to our voltometer, we see we have 0 ohms of resistance. Connecting it to the CT100B after properly discharging the static. We can see that there's no defects in this line. Even when we zoom in and on and turn up the resolution, we can see that it's just a flat control piece of cable. And we've got the VP set at 0.85. Taking a look at the very end of the cable, we can play with the end, see that we're at the end of the cable, there's no damage inside of the cable itself. And again, we're at 36 inches. Taking a look at our 1,000 foot roll of cable, we have our velocity of propagation set at 0.85, and our resolution is set at screen resolution. Connecting to the CT100B using proper static discharge procedures. Using AutoFit to show the entire cable, we can see the CT100B changes from short to medium, and we're going to be looking at this cable using different resolution settings. First off, you can see this cable looks rather different than our shorter length. You can see there's a gradual rise from 75 ohms to a little over 150 ohms. This is due to the capacitance of the cable over its entire length. Another thing to note is the screen resolution and the change in step size. The step size is unchanged when I adjust the gain. But you can see the difference in the upper right-hand corner when I zoom in and out, and compare that to the bottom left before the cable was connected to the TDR. Screen mode is a setting that allows very fast updating of the trace being drawn on the display. There's one reading being taken for each pixel on the display, and a complete scan happens hundreds of times per second. Older CT100 models always worked in what is now called screen mode. The downside of using screen mode is that the resolution of the data points is very coarse when displaying long cables. There are 480 points drawn on the display, so a scan of a 48-inch cable would have a resolution of about 1/10 of an inch per pixel. However, if you're scanning a 1,000-foot cable, you get one measurement about every couple of feet. This can be a very quick way to find the end of a cable, but most of the detail will be missed. To see the details in a long cable, you'd have to zoom in until only a small selection of the cable is displayed, and then using the horizontal position knob, scroll along the entire length of the cable. Fixed mode was created to solve this problem. Going to press the blue button and then tap the resolution option. There are 3 modes here: screen, normal, fixed at 17.5 picoseconds, and there is fixed adjustable where you can adjust the step to as low as 0.76 picoseconds. Looking at this cable, we can see the same gradual rise and no defects in the cable, and as we zoom in, the step size is unchanged. In fixed mode, this resolution is used no matter how long a selection of cable is displayed on the screen. Long traces at high resolution can consist of over 1 million data points. Each pixel on the display will have multiple points drawn, so variations in the cable's impedance, such as a connector or defects, can be identified at a quick glance. Once the initial scan has been taken, the display can be zoomed in around points of interest to view interesting details at a larger scale. The drawback of using an extremely fine step size is that the sampling of all those data points does take longer. Now we're going to connect to our 1,000 foot cable with splices in it. Showing it here in screen resolution, you can see the beginning and the end with the same gradual rise as with our other cable. Increasing the gain shows one little pixel change on this part of the screen. Now changing the resolution. Our resolution is at a fixed 17.5 picoseconds. And collecting all those data points takes a little longer. Increasing the gain reveals some more detail. And you can see the difference here side by side with the fixed resolution compared to the screen resolution we saw earlier. This is exclusive to the CT100B and a vast improvement over the CT100 and any other TDR on the market. We can zoom in further and see the two splices all the way down to connector level detail. Going back to screen resolution, you would likely miss that on a quick scan or any other TDR. We're still able to find the splices when we zoom in, and we're aided by knowing where to look. Otherwise, this would be a very long, tedious process, especially not being able to physically inspect the cable. And there you have it. Be sure to subscribe to our YouTube channel for more updates. For more information, check out our website at moretm.com or reach out to us via phone or email. And we'll see you next time.